to attend this week, okay lang naman kasi ang mahalaga lang maumpisahan natin yung chapter 5. Okay? So that's our goal for today lang. So at least start this topic so that when we resume by April 4, uh, mabilis na lang. Okay? And then ito kasi is Holy Week. So baka mag-asynchronous tayo sa Holy Week, no? Which will be continued the following week. Ayan. Okay? So yun lang ha. Just keep in mind yung mga adjustments sa dates. And if you missed some assessments, yung especially yung quiz later, I will reopen it. Okay? And then I'll post the answer before the weekends. Okay? And I hope that those things will actually help you at will actually help you na makasagot-sagot. Okay? Again, if you have urgent questions, especially sa mga calculation, just let me know in MS Teams. No? Kasi kapag sa Canvas, hindi siya nagno-notify agad eh. Yun. Yung sa discussion board naman, di ko siya nare-replyan ASAP. No? So, if you have question na calculation talaga, like urgent na gusto nyo i-clarify, go to MS Teams. No? Pag gising pa naman ako, reply ako. Yesterday, I wasn't able to respond to some questions by my student kasi I was with my classmates sa grad school and party. Okay. Kaya ngayon I can still feel everything. Anyway, kahit groggy tayo, we can still do calculations. Ganun talaga. Okay. So, for our session today, we're going to have an overview of what chapter 5 is all about. Okay. And again, we are not really compelled to complete this topic kasi this will be continued after the midterm period. That means it is not also included in the midterm period. Okay. Sorry, hindi siya kasama sa midterm exam. Okay. We just have to get things started. That's why we have to discuss this topic right away. Okay. And this topic is about monoprotic acid-base titration. If you check the materials, medyo similar sila with the laboratory. Okay. At least the first part of the discussion is similar with the laboratory. Okay. So yun lang. So monoprotic acid-base titration, you actually know what titration is, right? So we'll have a recap and then we'll proceed with the titration calculation, especially involving pH calculation. Okay. So, di ba last time what you were getting are endpoints or the volume of titrant needed na? Yun yung chapter 4 natin eh. This time, we will now be asked to get the pH of the solution. Okay. Actually, this part of the laboratory is, sorry, pag nag-lab class no, face-to-face, ito yung pinaka-exciting. Kasi like magta-titration talaga kayong lahat. Yan. So, ganun. But now, we are very limited. So, imagination muna ulit tayo. And given that alert level 1 allows 100% pop 100% use ng classroom na talaga. Hindi pa naman tayo papabalikin sa FAU na. Probably by August doon na tayo makapag back to school talaga. Okay? Kasi yung higher year ang priority in the meanwhile. Okay? But just be prepared, no? Kasi most probably by August, back to school na tayo. Which is something we all want. Except sa commute. Okay. So let's have a short overview of titration again. So titration is a volumetric analysis. Ibig sabihin, we make use of liquids, na? Diba sa gravimetry, we make use of solid. Pag volumetric, we make use of liquids, no? And not only liquids, no, but we also use volumetric apparatus. When you say volumetric apparatus, these are graduated, no? Okay. Sana all graduated. So when you say graduated, they have markings which will actually make it easier for you to tell the amount being dispensed by your volumetric apparatus. So, di ba, kunwari, this is your burette, tas tumutulo siya sa ilalim. So, you can actually see how much liquid were transferred to this Erlenmeyer flask. Okay? So, yun yung meaning ng volumetric. May graduation. Unlike others na, you know. Anyway. And what's happening here? Uh, what we're doing in titration is that the chemicals from your titrant, okay? Again, titrant is the chemical that is known. Alam mo yung concentration niya. The chemicals of your titrant, they are being reacted to the chemicals sa analyte mo. The analyte is the one in the Erlenmeyer flask. And yun yung inaalam natin, ang kanyang pwedeng molar mass, pwedeng uh, chemical concentration. Okay. So, di ba, when we answered some problems sa ating asynchronous topic, ganun yung mga tanong, either the concentration of the analyte or the molar mass of the analyte. So, ganun yung ginagawa sa titration. But mostly in chemical laboratories, what we actually want to get is the pH, no? The pH changes. Okay? Nag-aaway yung mga pusa sa amin. Anyway, so the common type of titration, especially for college students, is the neutralization titration, wherein you react your acids and bases so that they can form neutral products. Okay? So it is governed by acid-base reactions. Okay? So yan. And yun yung discuss natin, the neutralization titration. Okay? And again, just to recap, in titration, we just add few amounts of the titrant to your analyte until you see change in the color of your indicator. Once the indicator changes its color, meaning we reach the endpoint. And the endpoint of the titrant is used to do some calculations. Okay? Pero alam niyo ba, in modern laboratories, hindi na sila nag-i-indicator. In modern laboratories, they have this thing called autotitrator, which is parang napaka ganda niya. Okay. So, autotitrator. Kasi this autotitrator can do the chemical analysis for you. No? It will report you the pH curve. No? Mas madali. Like, ilalagay mo lang chemical, tas bahala na siya. So, this autotitrator is very expensive, but if you have this in your laboratory, napakaganda. Okay. So, it has a compartment for the titrant. Okay. So, may compartment siya for the titrant, and this machine will deliver your titrant to your analyte solution. No? Tapos siya na yung bahala mag-compute for you. And kumbaga ito yung pinaka holy grail of titrations. Ganda kasi niyan eh. Ito pa nga, no? Look at this. No? It can do multiple analysis at once. Okay? In the Philippines, there are laboratories that have this. No? Okay? Pero syempre, madalas human yung nagtatitrate talaga. Okay? Again, just to review some terms, the analyte is the substance which we don't know its concentration or identity. Okay? Pag sinabi nating identity, I am pertaining to the molar mass. Okay? The titrant is the substance with known concentration and known identity. Your indicator causes your substance to turn into a different color, no? Depending on the pH range. Commonly in titration, we use phenolphthalein. Okay, it actually turns into pink when you reach the endpoint. Okay, So again, endpoint is the position wherein your equivalence point can be observed. The equivalence point is the point wherein everything is stoichiometrically equivalent. Okay? So magkalapit lang silang dalawa. Okay, actually ito yung video na pinanood din natin last time. So I'll just skip this one. Okay. So ito din yung pinanood natin. Okay. Now, let's talk about what to expect in this chapter. Okay, kasi it seems na parang ay titration calculation na naman. Yes. Okay. But again, just as I said to you earlier, dati in chapter 4, we will solve for the volume, the concentration, or the molar mass of the analyte. Na. But in this topic, what we're actually going to do is to determine the pH of the solution as it is being titrated. Okay? So, now, medyo maraming equation dito. And then, sometimes may chance na malito kayo. Okay, that's normal. Pero, just to make things simpler for you, translate ko na yung mga nasa textbook into something that can be ano na lang, yung plug and kumbaga sa device plug and play na lang, no. Ang ginawa ko dito sa topic na to is whatever is in the textbook, I translated it into something na ipa-plug in mo na lang yung numbers. Okay. It is still governed by whatever we discussed last time, okay, such as equilibrium, okay, yung mga ice table, you can still apply it here. Pero just for simplicity, we will no longer use ice table, okay? Assuming that everything can be used by square root of Chaka, no? If you know square root of Chaka from my lab, you know what I'm talking about. Okay, so hindi na tayo gagamit ng ice table in determining the concentration. Rather, we'll just use the shortcuts I presented in the laboratory. Okay, so ganun gagawin natin. So, just remember that para mas guided kayo in what equations you will use, sobrang dami nila. Okay, so here are some pointers that you have to keep in mind. Okay, so first is that you have to remember that if there is a presence of acid conjugate base or base conjugate acid pair, you have to use Henderson-Hasselbalch equation. Okay, why? Because in the presence of acid conjugate base or base conjugate acid, we actually have a buffer system. Okay, so lagi tatandaan yan. If you see that you have acid conjugate base or base conjugate acid, you have to use the Henderson-Hasselbalch. So again, what's Henderson-Hasselbalch? That's pH equals pKa plus log conjugate base over acid. Okay, or kapag POH naman yan, so that's POH equals pKb plus BH plus over B. Okay, and then how will you tell if you have a conjugate acid base pair? So basically, may isang proton lang na either nadagdagan or nabawasan. Okay, so you have to be keen with the details, no? Like that. Tignan mo maigi yung formula. Okay, so whether nadagdagan siya ng H, nabawasan siya ng H. Okay, so yun. Whenever you see acid conjugate base pair or base conjugate acid pair, you have to use Henderson-Hasselbalch equation because you actually have what's called a buffer system. Okay? Okay, so i-apply natin yung nalaman natin sa last chapter dito kasi meron tayong buffer system. And what else? Diba, during the buffer discussion in the laboratory in the previous chapter, sa asynchronous video, we know that when we add acids, the amount of bases decreases. Okay? Kapag nag-add ka ng acid, bumababa yung base. And vice versa. Pag nagdagdag ka naman ng base, mababawasan yung acid. In a sense na yung nababawasan means that nagre-react sila to form the product. Okay? So if you add acid, mababawasan yung base kasi they are being converted into the product. Okay? Kasi kailangan tandaan nyo yan. Okay? Kasi in this topic, may mga idadagdag tayo na titrant. So we have to know what kind of titrant is that na para alam nyo kung nababawasan sino. Yung acid ba, yung base. Okay? And then next one is you have to remember that the addition of two liquids, diba? In titration, we add the titrant to your analyte. When you add them, what happens to the volume? It increases. Okay? So, tumataas yung volume. Therefore, may dilution na nangyayari. Ang daming kailangan kabisaduhin na. So, ibig sabihin, gagamit tayo C1B1 equals C2B2. Okay? Pero may shortcut pa dyan, don't worry. Okay? So, yan yung mga kailangan tandaan, and knowledge of equilibrium calculation will be helpful in some situations. Okay? But again, I will try to make this topic much easier to understand. Kasi if you just rely on your textbook, which I did during my college times, wala akong naintindihan. Kaya ginagawa ng teacher namin, shortcut niya rin. Kaya yun yung nagagamit namin. Even sa board exam review namin, shortcut. Kasi if you do whatever is indicated in the textbook, kung nag-advance reading kayo, magugulat kayo sa mga nangyayari. Yan din kasi yung textbook namin ng college. Ayun. Okay. So anyway, again, everything in this PowerPoint is simplified, okay, so that you can just simply plug in the numbers, okay, but still you have to remember all these things, okay, kasi later on we have several equations. I think we have more than 20 equations in this PowerPoint, so you really have to know which equation will you use. So ito yung mga kailangan tandaan, okay. So don't get intimidated. Kasi this topic is hard, yeah. Pero once you get it, madali na lang, okay? So tandaan ninyo yan. Okay? And here are some of the equations. Marami pa yan later. Pag stoichiometry, you know that that's the moles of the titrant and the analyte should be equivalent. Okay, we can just use stoichiometry there. For the dilution calculation, we can use the C1B1 equals C2B2. For the equilibrium calculation, we can use the shortcuts such as square root of Chaka or square root of CBKB. If the concentration of your acid or base divided by the K is greater than 1,000, okay? So if they are greater than 1,000, then we can use these equations. Kasi kapag nag-ice table pa tayo, anong oras na tayo matatapos, di ba? So yun, so pwede na tayo gumamit ng square root of Chaka. And then again, keep in mind for the buffer calculation, this is the equation. Okay? So now, there are different types of titration. Okay? So, marami yan. We have monoprotic, diprotic, and polyprotic. For now, we'll just look into monoprotic titration. When you say monoprotic, only one proton is being transferred. Okay? Isang proton lang yung nagre-react. So, meaning the stoichiometry of our analyte and the titrant is 1-to-1 ang ratio. Nagulan po talaga sa PH and PA stuff. Don't worry, as we go sa topic na to, mas makikita nyo na, ay, ganun pala dapat. Okay. So, eventually, magigets nyo rin siya. Okay. Pero kapag may iba pa kayong questions that needs urgent answer, sa MS Teams kayo mag-chat para mabigay ko yung solution sa inyo. Okay? Kasi may ganun akong students eh. Sir, paano ulit ang ma-compute? Tapos sinusolve ko talaga. Tapos binibigay ko sa kanya yung answer. Okay? So again, just for the simplicity, we'll just focus on the monoprotic titration. When I say monoprotic, only one proton is being transferred and reacted with. Okay? So, meaning the stoichiometric ratio of our chemicals is 1-to-1. Okay? So, you don't need to balance anything kasi 1-to-1 na yung ratio nila. Okay? And monoprotic titrations can be classified into 3 subcategories. Okay? So, that depends on the type of chemicals you are reacting with. Okay? So, pwede tayong may strong acid, strong base titration. Pwede tayong may weak acid, strong base titration. And weak base, strong acid titration. So, by this time, you should know which is the strong and which is the weak acids or bases. Just for simplicity, kapag sinabi nating weak, they usually have Ka or Kb. Okay? So, given yung Ka nila o kaya yung Kb. Kapag strong, edi no need na ng Ka pati Kb. Okay? So, tandaan natin that when we are doing strong acid, strong base titrations, we can just simply use stoichiometry to get the pH of the solution. Mag-stoic lang tayo. Kapag involved na ang weak, weak acid or weak base, we have to use equilibrium calculations na. That is the square root of Chaka, okay? Or the CBKB, okay? Square root of CBKB for the base. So again, kapag strong acid, strong base, ito lang, stoic lang yung kailangan natin. Pero kapag ang ating gamit ay, what do you call this? Yung ating gamit ay weak acid or weak base, we have to use equilibrium calculations. Again, we are not going to do ice table anymore. We just go with the shortcut. Okay? So, yan. Just for the simplicity of also, I'll use abbreviations for this topic. Okay? So, kapag sinabi naming SASB, pati SBSA, yung mauuna, this is your titrant. Yung susunod, yun yung analyte mo. So, SA meaning strong acid, yung titrant, strong base, yung analyte. So, ganun yung sequence. SBSA meaning yan, strong base, yung titrant, SA, strong acid, yung analyte. Ito naman, weak acid, strong base, ang ating baliktad pala ako. Mauna pa na yung analyte bago yung titrant. Alphabetical nga pala yan. So, unahin natin yung analyte, then followed by the titrant. Okay? So, yung mauna analyte, susunod yung titrant. Alphabetical pala yan. So, A muna bago T. So, for weak acid strong base titration, we can abbreviate that as WASP. This is your analyte again. Analyte. And susunod yung titrant. Ganun din sa weak base, strong acid. Okay? So, mauuna yung analyte, susunod yung titrant. So, yan yung apat na abbreviation natin that will actually make things simpler, no? Kasi, ang daming types ng titration talaga. Ang daming pwedeng posibleng lumabas sa quiz ng chapter 5, which is April pa naman, don't worry. Ayan. So, it is very important for you to identify what type of chemicals you are reacting with. Okay? So, you have to know if that's a strong acid, strong base, weak acid, or a weak base. Okay? And here are the abbreviations. So, SASB, SBSA, WASB, and WBSA. Yung una yung analyte, followed by the titrant. So, alphabetical yung arrangement. Now, let's talk about the SASB titration. Okay? So, again, yung una, yun yung analyte, and then yung susunod, yun yung titrant. Okay? So, in the SASB titration, our analyte is a strong acid, and our titrant is the strong base. Okay? And during the titration of strong acids and strong base, we actually have 4 stages. Okay? So, ano yung 4 stages na yun? So that's the initial, pre-equivalence, equivalence, and then post-equivalence. Okay? So kung i-graph natin yung ganyan yung itsura niya. So what's initial? When we say initial, we refer to a state, no, wherein you have not added any titrant yet. Wala ka pa nilalagay na titrant. Yun yung initial. Wala pang titrant. Yung pre-equivalence, naglagay ka na ng titrant. Okay? So, ibig sabihin, nagbabago na yung pH niyan. So, again, initial, no titrant is added. Pag pre-equivalence, medyo may patak-patak na yan. Equivalence, ibig sabihin, we just added enough amount of titrant. Okay? Enough amount of titrant was added. Okay? So, yan. So, initial, wala ka pang dinadagdag na titrant. Pre-equivalence, may dinadagdag ka na titrant. Equivalence, you just added enough amount of titrant. Okay? So, meaning tapos na yung reaction. And then yung post-equivalence, ito yung kapag nasobrahan ka ng patak. Okay? Kapag nasobrahan ka ng titrant, post-equivalence na tawag doon. Okay? Again, what are the 4 stages for SASB? Initial, pre-equivalence, equivalence, and post-equivalence. Ito naman, itong stages na to, pare-parehas to sa 4 na uri ng titration. So, pare-parehas yan sa SASB, SBSA, WASB, WBSA. So, pare-parehas lang sila. Okay? So, mayroon silang pre-equivalence, initial, pre-equivalence, equivalence, and then post-equivalence. Now, let's talk about the species present during the titration process. Ano yung mga chemicals na nandun? Okay? So, what are the chemicals that are in your solution? Okay? During each stages na. So, for the initial, of course, you have your acid. Okay? So, HA. So, acid lang yung present sa iyong sample. Okay? Wala kang titrant na base. Okay? Pag pre-equivalence, ibig sabihin, nagpatak ka na ng titrant. So, ano sa tingin nyo mangyayari sa acid? Maulaan nyo. Diba, initially, I only have acid. At pre-equivalence, nagpapatak na ako ng titrant. What happens to the amount of my acid? Dumadami ba siya o nababawasan? Nagpapatak na ako ng titrant. What happens to my acid? Dumadami, nababawasan. What do you think? Nasa PowerPoint na yung answer. Mare-reduce po kasi nagre-react sa base. Tama na. Tsaka nasa PowerPoint na rin. Tama yan. Kasi nagdadagdag ka na ng titrant, so yung acid mo nababawasan. Therefore, the pH changes na. Okay? Kaya if you can see here in the graph, okay, yung initial mababa pH kasi acidic siya. But as we add the titrant, ano mapapansin mo? It slowly goes up. Tumataas yung pH kasi nagre-react na yung acid sa base. So, nababawasan yung acidity. So, the pH goes up. Tandaan nyo yan. Important yan. Okay? So, you have less acid and the salt. Okay? At equivalence point, anong meron dyan? At equivalence point, all the acids reacted with the titrant na. And basically, what you have is just a salt. No? Okay? Salt and water na lang yung natira. And at post-equivalence point, ito naman yung nasobrahan ka na ng titrant. Okay? So, you have to determine how much titrant is in excess. Okay? So, ganun. So, dito ngayon sa ating species present, this can actually give us an idea on what equations should be used. Okay. So, using the species present, pwede natin malaman kung anong equation yung gagamitin natin. Okay? So, for the initial, between water and HA, sino yung magko-contribute sa pH ng solution? Diba sabi natin in previous chapters na yung acid, sila yung nag-i-influence ng pH ng solution. So, between water and HA, it is the acid that contributes to the pH of the solution. It contributes to the pH of solution. Okay? So, siya yung nagko-contribute sa pH ng solution. So meaning, if you want to get the pH, all you have to do is to just get the negative logarithm of the concentration of your acid. That's simple lang. Okay? So, kunin mo lang negative log ng concentration niya. Yun na yan. Okay? So, ganun lang ka-easy. Para makuha mo pH, negative log mo lang yung kanyang concentration. Okay? pH equals negative log of H+. Now, let's talk about pre-equivalence point. Between the three species present, water, your acid, and the salt, which of them do you think will contribute to the pH of the solution? Yung water ba? Yung acid ba? O yung salt? What do you think? Which among them will contribute to the pH of the solution? Yung water, yung acid, o yung salt? Sino yung magko-contribute? HA. Actually, HA lang muna. Okay? So, just the acid. Yung salt, magka-contribute to kapag yan ay weak acid, weak base. Okay? Weak acid or weak base yan. So, anyway, siguro madidiscuss natin to by the end of midterm consultation. So, wala namang pressure masyado sa atin. Okay? So, for now, ang magko-contribute lang for strong acid, strong base ay yung acid natin na less. Yung salt, wala siyang effect for now. Okay? But again, keep in mind na in the future, may contribution na rin siya. Okay? So, in the future. Pero for now, wala muna. So, the major contributor to the pH of the solution will be your acid only. Okay? However, the amount of acid was reduced, right? So, nabawasan siya. So, to get the concentration of your acid that is less than the original, this equation needs to be used. So, let me just explain the rationale of this equation. Okay? So, yung A natin, that's your analyte. Your T is your titrant. Okay? So, A is the analyte, T is the titrant. And what can you see here? What do we get ba when we multiply the molarity and the volume? What do you think we can get if we multiply molarity and volume? Okay, so correct, moles. So basically, ito yung moles ng acid, okay, your analyte, minus the titrant, which is your base, no? Okay, so it is the mole of acid minus the moles of the base. Okay, bakit ganito yung equation? Kasi nga, sabi natin kanina, nababawasan yung acid. By how much? Ganito. So, subtract mo yung moles ng base sa moles ng acid. Kasi nababawasan na yung acid, di ba? So, yan. Kaya ganyan yung equation. So, mole acid minus the mole base or MAVA minus MTVT. Okay? Yung moles yung nababawasan. Kaya ganyan yung equation. So, to get the mole of the acid, that is just MAVA, molarity analyte, volume analyte. To get the moles of the base that reacted with the acid, the equation is just molarity titrant, volume titrant. So this difference will give you moles, okay? Moles of acid left. Okay? So yan na lang yung natira na acid kasi 'di ba nag-react nga siya sa base. So this difference will actually give you the mole of the acid that is left. But remember, in getting the pH, we want molarity, not the moles, right? So, yung moles ng acid na natira, we have to divide it by the total volume. Okay? Total volume. Why? Kasi dilution. Okay? Nadagdagan yung volumes mo eh. So, you have to divide it by the total volume. Okay? So, ganun lang. So, yan yung parang pinaka-rational ng equation na to. Okay? So, again, why is that equation like that? So, the numerator will give you the moles of the acid that is left after it reacted with the base. And yung V total sa baba that is used to get the molarity. Okay? The total volume refers to the volume of your analyte plus the volume of the titrant added. Okay? So, ipag-add mo yung dalawang volume. Okay? So, ganun lang yung pinaka-idea sa equation na yan. Okay? So, add ka lang ng add ng titrant. So, mababawasan ang concentration ng ating acid. Mababawasan yung mole niya. Therefore, tumataas yung pH. And then, suddenly, you will come to a point wherein everything were reacted already. So, pag lahat ng acid nag-react na, wala nang HA, salt na lang yung natira. Between water and salt, which will contribute to the pH. Sino yung magko-contribute, yung salt o yung water? So, the answer here is actually water. Yung water yung may influence kaysa sa salt. Okay? So, the water will contribute to the pH of the solution. And what is the pH of water ba? Diba 7? So, ibig sabihin, at equivalence point, it is always pH equal 7. Yan yung always na sagot dyan sa equivalence point ng SASB. The equivalence point is always equal to 7. Sana ganyan na lang sa quiz na puro pH equal to 7. Pero hindi. Okay. So, kasi bakit naging pH 7? Kasi ano ba yung pH ng water? Eh di 7. How did you get that? Okay. So, paano natin nakuha yan? Remember your ion product of water. Okay. Kw equals H plus OH. In water, the concentration of H plus and OH are the same. So, meaning, pwede natin yung ma-simplify as Kw equals H plus squared. Kasi water lang yan eh. Na? So, ibig sabihin, same sila ng concentration ng H plus pati OH. So, to get the concentration of H plus, you just need to get the square root of Kw. Okay, and the square root of Kw is 1 times 10 raised to negative 7. Okay, kasi you know Kw is ano diba, 1 times 10 raised to negative 14. If you get the square root, divide by 2 mo lang exponent, so that will become 7. And what's the negative logarithm of 1 times 10 raised to negative 7? Edi 7. Okay, so that's why the pH of water is 7 parate. Okay. So now, yun, sa equivalence point, always pH 7 yan. Okay? At post-equivalence point, ano na yung mga species present sa atin? So, at post-equivalence point, we have water and excess base. Nasobrahan ka na ng titrant na base. So, which of them will contribute to the pH of the solution? Is it the water? No. It will now be the base. So, si base na yung magko-contribute sa pH ng
solution. So, siya na yung may effect. May salt pa rin. Okay. Sorry. Hindi ko pala nalagay. May salt pa rin. Yeah. May salt pa rin pero wala naman siyang effect sa pH. No? Pag strong acid, strong base, yung salt natin, wala siyang contribution. Nag-exist lang talaga siya. Ayun. Nakalimutan ko pala. Thank you for that. I-add ko na lang siya sa PowerPoint. Okay, so at post-equivalence point, the major contributor to the pH of the solution is the excess base. When I say excess base, this is the base na over sa nag-react na acid. Sumobra siya sa nag-react na acid. So for you to get the excess base, of course, you have to subtract the mole acid from the mole of the base added, no? So, mole ng base minus mole ng acid. Okay, bakit minus mole ng acid naman this time? So, baliktad siya doon, no? Kasi, remember, yung acid mo, nag-react siya sa base, no? Okay, tapos isubtract mo siya para mabawas mo yung reacted na base. So, pag pinag-subtract natin yan, you will get the mole of excess base. Ayun na yung sobrang base mo. Okay, so mole base minus mole acid will give you the excess moles of the base. Kung gano'n kasobra yung sobra. Okay. And to get the moles, remember, MTVT lang tayo. Okay, so molarity titrant, volume titrant, minus molarity analyte, volume analyte. Okay. So mole ng base minus mole ng acid will give you the excess amount of the base. And syempre, when doing pH calculation, we want molarity. Okay? So, yung moles natin, we have to divide it by the total volume. Okay? So, ipag-add lang natin yung mga volumes. And of course, something that you have to be careful is that kapag ginawa mo tong equation na to, okay? So, itong mole base minus mole acid, kapag ginawa mo tong equation na to, you will get the concentration of the excess base or the hydroxide. If you're asked to get the pH, pwede mo naman gamitin yung pH plus POH equals 14. Pwede mo gamitin yan. Kasi OH yung masasolve mo talaga dito. Kasi we're solving the base. No? Kaya base yung makukuha mo. So siguro pwede gawin mo, get the POH, then turn it into pH. Okay? So, yun yung steps na pwede mong gawin. Okay? So, that's the rationale behind the equations. Marami pa yan. Okay? So, you really have to contextualize what chemicals are you using. No? Kasi depending on your analyte and your titrant, you can have a different version of the equation. So, ganun medyo demanding yung titration. So, kailangan alamin mo talaga kung ano yung analyte, ano yung titrant, strong ba siya, weak ba siya, because for each case, iba-iba yung equation. And again, very important na kailangan alam nyo yung species present so that you can have an idea on what equation should be used in getting the pH of your solution. Okay? So just to summarize, initial, you have just the acid. So whatever the concentration of acid is, pwede mo makuha yung pH by getting its negative logarithm. In the pre-equivalence point, your acid becomes salt, pero nababawasan siya na. So to get the amount of acid left, the equation to be used is the MAVA minus MTVT over V total. So that's an equation in getting the amount of acid left. Okay? So binawas natin yung nag-react kay base. At equivalence point, the pH is always 7 for strong acid, strong base titration. Always 7 yan. Okay? Because the major contributor to the pH is just water. At post-equivalence point, you have your excess base, okay? And to get the excess base, you have to subtract the mole of your base. Magsusubtract ka ng mole base and mole acid. No? So, para alam mo kung gaano karami yung nagamit at yung sumobra. Okay? And you have to divide it by the total volume so that you can get the overall concentration of the base, convert it to POH, and then later on to pH. Okay? So, as we do that, we can actually make a graph. Okay? Ito yung pinaka-goal ng chapter na to for us to draw graphs. No? So, i-graph natin yung titration like that. Okay? So, you have your initial, pre-equivalence, equivalence, and post-equivalence. Okay? So, let's have some titration. Let's try this one. Do the calculations needed to generate the hypothetical titration curve for the titration of 50 ml of 0.05 molar HCl with 0.1 molar sodium hydroxide. Ganito yung problems madalas dito. Okay? So, ang tanong dyan, sino yung analyte, sino yung titrant? Diba? Okay, ganito lang. Pag molarity lang yung given, siya yung titrant. Okay. Ito molarity lang given. So, ito yung titrant. Okay, yan yung shortcut na ginagawa ko. Kung sino yung molarity lang yung given, siya si titrant. Okay. So, our titrant is a base. Sino yung analyte? Edi yung given yung volume, pati yung molarity. Okay? So, volume and molarity. So, analyte. Tsaka always, ito pa yung shortcut ko rin. Kung sino yung sinabi na una, siya yung analyte talaga. Okay? Okay. So, yung unang binabanggit, yun yung analyte, followed by the titrant. So, yun yung aking mga shortcut dati ng college. Until now naman, nagagamit ko siya. So, unang babanggitin yung analyte, followed by the titrant. Okay? So, ganun yung pattern. So, analyte with titrant. Okay? So, para hindi kayo malito sa problem. Kasi baka mamaya mapagbaliktad nyo. Okay? So, let's try this na. So, alamin daw natin yung mga pH for every volume of titrant added. Okay. So, this is your analyte. Ito yung nasa Erlenmeyer flask. Siya yung nandito. And then yung titrant, siya yung nasa burette. Okay. Kasi papatak mo yun. Now, as you can see in this table, we have different volumes of titrant added na. So, 0 ml ng titrant, 10 ml ng titrant, 25 ml ng titrant, 25.1 ml ng titrant. Okay. So, ano yung gagawin natin dyan? Okay. Ganito. Kailangan, alam mo yung stages. Okay. Di ba? Depende sa stages kasi yung equation. Okay. So, kailangan, alam mo yung stage, no? Di ba kada volume ng titrant na dinadagdag mo, iba-iba yung stages natin. Pwede nasa initial, pre, equivalence, pati post. No? So, ito lang. Kapag 0 ml, yung titrant, of course, yun yung initial. Okay? Pero how about the others? How about the 10? How about the 25? How about the 25.1? Anong stage sila? I don't know, di ba? Yun yung unang sasabihin natin. Kasi baka mamaya equivalence na pala to, no? Mamaya equivalence na pala tong ano na to, 10 ml. Baka mamaya ito yung equivalence, di ba? Di natin sure. Para malaman mo yung correct stages, okay? Ganito. Para malaman mo yung correct stages ng titration, you have to solve first for the endpoint. Okay? And ano yung sabi ko dati? Endpoint can be calculated from whatever is given. No? gamit ka lang ng stoichiometry. Okay? So, yun yung first na gagawin mo. You have to determine the endpoint. Okay? Using stoichiometry. Okay? We have to solve first for the endpoint. Okay? So, ano mangyayari sa endpoint? Kailangan yung mole ng acid mo is stoichiometrically equivalent to the mole of your base. Okay? So, kailangan stoichiometrically equivalent sila. So, gagamit tayo ng stoich. Okay? So, mag-stoich tayo. Okay? So, yun. Kailangan equal sila. So, how do you get the mole of acid? To get the mole of acid, that's molarity analyte, volume analyte. How do you get the mole of the base? Molarity titrant, volume titrant. Okay? So, ang gusto natin malaman is yung volume ng titrant that will give us the endpoint. So, ganito lang equation. So, kailangan equal yung mole of acid and yung mole ng base. Okay? So, we use MAVA equals MT/VT. So, gusto natin malaman yung volume of titrant at equivalence. Okay? So, just divide both sides by MT. So, we will get this. We will get this. Okay? So, molarity analyte, volume analyte divided by molarity titrant. Okay? Yan. So, what's the molarity of your analyte? No? So, you have 50 ml times 0.05 molar. The molarity of your titrant is 0.1 molar. Okay? By the way, hindi to kasama sa hindi siya kasama sa exam. Matagal pa to. Okay, umpisahan lang talaga natin. So, if feeling nyo na medyo groggy kayo agad na, okay lang yan. Okay, kasi matagal pa naman natin ulit ito babalikan. After midterm, after midterm consultation pa. So, how much titrant is needed to completely react with our analyte? So, just use the equation MAVA equals MTVT. That will give you the endpoint. Okay, the volume of titrant at the endpoint. Okay, so ang sagot ay 25 ml pala. So, the volume of titrant is 25 ml. Ito yung endpoint, no? Or we can say ito yung equivalence point. Okay? So, bakit uli natin kailangan gawin to? Kasi, without this, you won't know the stages. Hindi mo alam kung ano yung stages mo. Yung 0, alam ko initial yan. Kasi wala kang inad na titrant. So, initial yan, of course. There's no doubt about it, di ba? Pero ito, di mo alam, di mo sure anong stage to. So, at least using this equation, we know that 25 ml is the endpoint or the equivalence point. So, meaning, ito yung aking equivalence point. Okay? Now, I know 2 stages na. So, anything in between can be simply inferred to na lang. Na? So, madali na lang hulaan yung ibang stages. Kailangan alam mo yung initial, alam mo yung equivalence point, and then yung others, ikaw na bahala manghula kung ano yung stage na yun. Of course, yung 10 ml, before 25 yan. Okay? So, that's pre-equivalence na. Diba? Kasi, tandaan nyo, ito yung equivalence. So, 25 ml yan. Yung 10 ml somewhere here. So, pre-equivalence stage yan. Okay? Because the volume is less than the equivalence. So, what do you think 25.1 is? Is it still equivalence point? Anong stage na kaya yung 25.1? Nasang stage na tayo yan?
Anong stage na yan? Yung 25.1. Kasi sabi ko yung 10 ml, pre-equivalence. Yung 25 equivalence, paano ko nalaman? Using the endpoint equation. Yan, wherein yung mole ng acid dapat equal sa base. So, ibig sabihin, 25.1, post na. Nadagdagang, na sumobra ka ng 0.1 eh. Okay. Okay. So again, ganun lang yung pag-identify ng stages. Is it really required? Yes. Kasi if you don't do this, hindi mo sure kung ano equation gagamitin mo. Ang dami. So, you really have to be careful. Okay? So, ganun. Again, alamin yung initial pati equivalence. Yung initial, yun yung 0 ml, obviously. Yung equivalence, ito yung ito yung isa-solve mo using stoichiometry. Stoichiometry ulit. Okay? So, ito lang naman equation nun. So, you get the VT so that you can get the equivalence point. And then, anything else can be simply inferred to. Kapag less than 25, so that's pre-equivalence. Pag greater than 25, edi post na. Okay? So, that's simple lang. So, once you know the stages, ano meron? You can now solve for the pH, no? Pwede ka na gumamit ng mga equations for the pH. And ito nga, no? Sa libro, medyo complicated siya. So, what I did, no, is just to sinamarize ko na siya para kokopyahin nyo na lang talaga yung equation. Okay? Kokopyahin mo na lang yan, transfer mo dito, tapos mag-plug in ka na lang. Okay? So, what's the equation for the initial? Sabi, for the initial concentration, kung ano yung concentration ng acid, yun na yung kanyang H+. Kung ano yung concentration ng acid, yun na yung pagkukunan ko ng H+ concentration. Okay? So, as is na yan. Okay? So, 0.05 molar. So, what's the pH? If your concentration of acid is 0.05, di kunin mo yung negative log lang. So, negative log 0.05. So, 1.30. Okay? So, 1.30 siya. Ayan na yung pH. So, mag-graph ako dito, ha? So, pH 1, pH 3, 4, 5, 6. Sige lang. Pag may question, i-clarify. Ask nyo na lang. How po nakuha yung H+? Tandaan natin, pag initial stage, 'di ba? Sabi natin that the pH of the solution is just the concentration of the acid. Ayan. So, kung ano yung concentration ng acid mo, yun na yung concentration ng H mo rin. Okay? So, in the problem, this is the concentration of the acid. So, yun na yun. Copy mo lang. Okay? So, ganun lang. So, i-graph ko siya, ha? So, at 0 ml titrant, tandaan nyo yung x-axis is the volume of titrant. So, at 0 ml, ang pH ng solution natin ay 1.30. So, siguro somewhere here. Somewhere there. Okay? Okay, pre-equivalence naman tayo. Ano yung equation for pre-equivalence? Ako, medyo kabisado ko pa ata, no? So, to get the concentration of the acid, ang sabi ng ating equation sa table ay MAVA minus MTBT over V total. Okay, copy mo lang yung equation na yan. Kasi nasa pre-equivalence tayo, so just copy this equation. Okay. Ikakopy mo lang yan. Now, pagka-copy mo ng equation, mag-plug in ka na. What's the molarity of your analyte?
So according to the problem, the molarity of analyte is 0.05. Okay. So molarity ng analyte, yun daw, 0.05 na. How about the volume of the analyte? So the volume of the analyte is 50 ml. A question, should I convert this into liters? Kahit di na. Okay? Wag mo na i-convert siya into liters. No need na. Kasi yung volume total mo, kapag ml din yan, so parang nagka-cancel out lang yung mga ml. Diba? So, no need to convert into liters na. Okay? So, as is na yung 50 ml, ha? So, wag mo na i-convert into liters. Okay? So, that's my MAVA. That will give me the moles of the analyte. Okay? Moles of the acid. So, 0.05 molar times 50 ml. That's my MAVA. Minus MTBT. Yun yung molarity ng titrant mo times the volume of the titrant. So what's the volume of the titrant? So that's 10 ml. Okay. How about the total volume? To get the total volume, ano yun? What do you think is the total volume? That's the volume of your analyte and the volume of your titrant. So ano yun? 60 ml. Okay, so correct. So ganun lang na, plug in ka lang ng molarity ng analyte, the volume of the analyte, the molarity of the titrant, the volume of the titrant which is given here. And for the volume total, edi ano lang, pagsamay mo lang yung dalawang volume. So 50 plus 10. So 60 ml. Okay, kunin natin yung H plus. And then once na makuha na natin yung H plus, makukuha natin yung pH. Okay. Pindot. Ganito ka-tedious yung titration. Kaya yung ituturo ko mamaya in the laboratory, that will be the same as this one. Uulitin-uli natin to mamaya. Okay. Pero yung second part ng laboratory, doon na tayo magkakaiba. Okay? So, confirm ko lang kung tama tinype ko. 005 times 50 minus 0.1 times 10, 50 plus 10. Okay. So, ito daw yung concentration ng H+, 0.025. Okay? So, 0. Ayusin ko lang sulat ko. Dito na lang. Ay. Ayusin ko na lang to sayang space sa gilid. Okay? Basta ipa-plug in nyo lang yan sa Calcu. Rewrite ko lang para sakto yon space. Okay? So, ano yun? 0.05 minus 0.1 times 10 ml divided by 50 ml plus 10 ml. So, ang sagot daw dyan, 0.025. Okay? So, yan daw yung molarity. 0.025. So, yan, 0.025 molar. Now, to get the pH, negative log mo lang yan. Okay, so the pH now is 1.60. Okay, 2 decimal places usually yung pH natin pag ganito. 1.60. Asan kaya yung 10 ml dito? Ang gawin ko by increments of 5 na lang, ha? Ganito. So, 5, 10, 15. Okay, so, ito yung initial natin, 1.30. Upon the addition of 10 ml ng titrant, naging 1.60 siya. Nandito na siya. Okay. So, medyo tumaas yung pH, no? So, again, ano meaning nun? Meaning nun, nag-react na siya sa base natin. Okay? So, 1.60, medyo tumaas. At equivalence point, what's the equation for the pH? 7 na yun. Kasi to get the H plus, this is just the square root of Kw, the ion product of water. So automatically, 7 talaga at equivalence point. Kahit huwag ka na mag-show ng solution, 7 agad yan. Okay? So at 25 ml, 7 agad yung answer natin. Okay? Andun na agad yung pH. Okay? So, yan yung progress ng titration curve natin. So, 1.3, 1.6, to 7 agad at equivalence point. Wala nang solution dyan. Basta, SASB, 7 agad kapag equivalence. Okay? Kahit di ka na mag-solve. May ganyan sa quiz pero onti lang. Pag natapat yan sa inyo, swerte ka. About the 25.1. So, post-equivalence na yan. So, you just need to get the equation here. So, keep in mind, the makukuha natin is the OH. Okay? So, I'll just copy that equation. So, the concentration of OH is MT VT minus MA VA over V total. So, plug-in lang talaga siya. Okay? Molarity titrant. Let's see. Okay, molarity titrant is 0.1. Volume ng titrant natin is 25.1 ml na. Molarity analyte, so ganun pa rin. Yung analyte din nagbabago yan, ha. So yun at yun yung ipa-plug in mo parate. And then for the volume total, just add 50 and 25.1. 50 ml, 25.1 ml. That will give you the concentration of the OH. Plug-in lang talaga. Mukha lang siya nakakatakot at first. Pero pag na-apply mo na, madali lang pala. You just really have to be careful kung anong equation gagamitin mo. And again, dito kasama sa finals, ha? Ay, sorry, hindi siya kasama sa midterm. Sa finals pa to. Okay. 0.1 times 25.1 minus 0.05 times 50 divided by 50 plus 25.1. So, this is the concentration of our OH. Ayan. So, 1.33 times 10 raised to negative 4. 1.33 times 10 raised to negative 4. Ayan yung concentration ng OH. So, paano mo kukunin yung pH? Sige, kayo naman mag-solve ng pH. Kasi nakuha ko na yung concentration ng OH. So, kayo naman. Sige. So, try to solve the pH of the solution. So, ano yung gagawin niya? From OH, gawin mong POH. And then from POH, gawin mong pH. Okay? So, what's your answer? Abangan ko answer niya. Okay? Mabilis lang siya. Okay? 10.14. Sige. Check natin. So, ang makukuha mo muna, POH, no? So, you just need to get the negative logarithm of your OH concentration. So, the POH is 3.87 or 3.88. Okay, so to get the pH, so that's just 14 minus the POH. 10.12. 10.14, ang gamit pala is 1.33. Times 10 raised to negative 4. Negative lang. Tapos, 14 minus the POH. 10.12 siya. Okay. Recheck na lang ulit. Okay. So, the pH is 10.12. So, ganun lang. Hindi ko na i-show dito sa PowerPoint. Yeah. But that's just OH to POH, then to pH. So, the pH is 10.12. So, asan yun sa graph mo? Nandito yun. Yun ba yun? Okay. So, yun siya. So, paano tayo gagawa ng titration curve? Di connect the dots lang. Okay? Just simply connect the dots. Okay? So, this is 0 ml. So, magdadagdag ka ng titran here. Dahan-dahan. And then, suddenly, at 25, bigla yung mag-shoot up. Okay? And then, pagdating doon, magpa-plateau siya. Okay? So, ganyan yung itsura ng titration curve, no? So, medyo maakyat onte. Tapos, pagdating ng 25, biglang magi-spike. Yung inflection curve natin. So, ganyan magawa ng titration curve. So, ganun siya. Okay. Hindi naman kailangan perfect na. Tapos, dapat dito banda, medyo umaangat siya, no? Medyo pa ganun. So, biglang ganun, tapos ganun. Okay? So, not necessarily kailangan perfect, ha? Yeah. So, pwede naman natin yung gawin na per dot. Okay. Ganun ginawa ko last year, Although, papakita ko sa inyo rin. Let me show you kung ano yung binigay kong activity sa students ko. Kumbaga, parang ito yung aming problem set noon. Okay? Ayan. Look at this na. Aming given. So, a 10 ml of 0.1 molar HCl was titrated with 0.05 molar sodium hydroxide. Calculate the pH of the solution when 0.5 ml of titrant is added incrementally. Okay? So, ano lang yan? Basically, yung mga equation na ginamit natin, yan din ginamit namin. Okay? So, initial, pre-equivalence, equivalence, and then post-equivalence. Tapos mapapansin mo na yung volume ng titrant namin, we started from 0 and then we added 0.5 ml up to 30 ml. No? Okay, so puro 0.5 yung difference. So 0.5, 1.1, 1.5, 2, 2.5 until 30. So just like what we did kanina, So, required na alam mo yung initial and the equivalence point. Okay? Kasi, once na malaman mo yan, then that's the time you can plug in whatever is the correct equation. Okay? So, yan. Sesend ko rin to sa inyo, don't worry. Okay? Tsaka ganito din yung prob set niya para may idea na kayo. So, ganito yung itsura ng prob set ninyo. Gagawa kayo ng titration curve. Okay? So, yan. Gagawin nyo yung pagkuha ng pH, of course. And then, i-graph mo siya. Okay? This is how the graph looks like. Yung first derivative, kahit di na natin gawin yan. Siningit ko lang talaga siya. Okay? So, yan. So, this is the pH versus the volume of titrant. Okay? As you can see, it will slowly increase until you reach pH 7. And then, magpa-plateau siya. So, yun yung ginawa din natin. No? So, slowly increase, then pH 7, then plateau. Okay? Gagawin nyo rin yan. Okay, as your problem set. Okay? At least may idea na kayo. Yung first derivative, siningit ko lang yan sa mga bata. No? Ano ba meron sa first derivative? In the first derivative, we use this, no? So, kaming mga chemists, ang ginagamit namin to actually determine the endpoint, we use the first derivative, no? So, kung saan yung peak ng curve ng first derivative, yun yung endpoint talaga. Okay? Yun yung equivalence point talaga. Okay? So, yan. Pero, hindi na natin gagawin yan. Okay? So, siningit ko lang yan. Sa calculus, ano yung first derivative? Basically, yun yung parang slope. Okay? Slope ng curve. Hindi nyo nagagawin yan. Okay? So, yun lang. So, that's for the strong acid, strong base. Okay? So, again, paano uli sinasagutan ng titration? Identify the stages. Most importantly, identify the endpoint. And then, pag na-identify mo na yung stages, copy mo na lang yung equation. So, copy all these things. Paste it here. And then, yung mga numbers, i-substitute mo. Yung ml, hindi na siya kailangan i-convert into liters. Kasi magka-cancel out din yung mga ml. Okay? And then, for post-equivalence, sobra yung OH natin. So, from OH, get POH, and then pH. Okay? So, yung reason ba't 10.12 nakalagay dyan sa PowerPoint. Okay? So, ganun lang. Sa tingin nyo, kaya nyo na gumawa? Siyempre, kaya nyo na, no? Ayan yung answer. Okay? So, sa tingin nyo, kaya na ba? Kasi, bibigyan ko kayo ng isang problem na sasagutan nyo. Walang solution yan sa PowerPoint. So, try nyo muna sagutan yan. And then, ipapakita ko yung answer sa worksheet. Okay? So, antayin nyo lang yung worksheet kasi nandun yung sagot dyan. Okay? So, abangan nyo na lang. So, look at the problem. So, yan ay So, yung problem natin, may 10 ml of 0.1 molar HCl ka daw, and you titrated it with 0.05 molar sodium hydroxide. So, again, yung nauna, yun yung analyte. Sagutan nyo to kasi nasa worksheet nyo ito. So, this is your analyte. Okay, and this is your titrant. Kung ano yung nauna parate, yun yung analyte. Okay? And then, ito yung mga volume of titrant. Identify mo anong stages yan. Of course, ito yung initial. Of course, this one is the initial kasi 0 volume yung titrant. So, may equation doon. For 1 ml, anong stage kaya yan? Hindi ko sure. Ano kaya yung 10 ml? Anong stage yan? Hindi ko rin sure. Okay na bahala mag-solve yan. And again, the answer will be posted in the worksheet. Okay? So, bibigay ko yung worksheet na lang. sagot muna kayo yan. And again, don't worry, wag kayo masyado ma-pressure na kasi i-continue natin to by April pa because of the midterm next week na. So, next week, next month pa natin itutuloy ito. Okay? So, still have more time. Okay, now, let's end this session with the strong base, strong acid. So, ano naman dito sa strong base, strong acid? So, your base is your titrant. Your strong base is your analyte. Baliktad naman. And your strong acid is your titrant. And just like kanina, we still have 4 stages. Okay, so initial, pre-equivalence, equivalence, post-equivalence. And the species present are the same as kanina. Okay, medyo same lang siya. Okay, tignan nyo ha, medyo same siya dito. Okay, nagkabaliktad lang, no? Okay, nagkabaliktad lang in a sense na base muna yung initial mo. Then, di ba kanina excess base yan? Ngayon, acid naman yung excess. Kasi your titrant is an acid. Okay? So, baliktad lang yung process. Okay? So, meaning yung equations, pagbabaliktarin mo lang din. Okay? So, initially, you just have the base. Okay? The base will contribute to the pH of the solution. So, whatever the molarity of the base is, that's your hydroxide concentration. So, gagawin mo from OH, gagawin mo pH, POH, then pH. Yun yung steps niya. Okay? So, initially, you will be given the OH concentration, get the POH, and then you will get the pH. At pre-equivalence, you are now adding acid. Meaning, pag nilalagay na ng acid, nababawasan na yung base. Okay? And just like what we did earlier, to get the amount of the base remaining, this is the equation. So, molarity analyte minus molarity titrant over volume total. Okay? So, this equation will give you the mole of the base left. Okay? So that will give you the moles of the base left and divide it by the total volume, just like what we did earlier. But this time, makukuha mo is OH. No? Kasi base yan eh. So OH yung makukuha mo. You have to convert to POH, then pH. At equivalence point, just like earlier, pH equals 7 pa rin yan. Okay, so pH 7 pa rin yan. And then for post-equivalence, parehas lang siya kanina. Okay? But this time, you will actually get the pH. Na? Sa kanina kasi puro mga OH eh. Kasi base nga yung ating substance. But in excess acid titrant, you will now get the pH mismo. Okay? That is the molarity titrant, volume titrant, minus molarity analyte, volume analyte over the volume total. Okay? Parehas lang dito. Okay. Nagkabaliktad lang yung identity of the chemicals present, of the species present. Okay? So, yan. Dahil nagkabaliktad yung ating chemicals, yung ating titration curve, mababaliktad din, of course. You will start with a very high pH kasi, bases have high pH. And then upon the addition of acid, what happens to the pH? The pH will decrease. No? Very slowly. So, dahan-dahan siya bababa. Until you reach what's called an endpoint, wherein the pH is exactly 7. Okay? And then, after that, you will have your post-equivalence, wherein you added too much acid titrant. I'm sorry, nagkamali ako dito. So, your titrant is now a strong acid. Okay? So, too much acid na yung nalagay mo, kaya sobrang baba na ng pH. Okay? So, ganyan yan. So, baliktad siya sa kanina, ha? Okay? So, just for comparison, let me show you again yung kanina. So, ito yung equations earlier. Ito yung graph earlier. And then, if you compare it with the equations now, parehas lang halos. But the identity of the chemicals are flipped. So ito OH, OH, plus ito H plus na. And the curve gets flipped as well. Of course, your analyte is a base, so mataas dapat talaga yung pH at first. Okay? So let me show you that with this problem. Okay, very quickly lang. Oopsie. Tapos ito, meron pa kayong pwedeng sagutan. Okay? So, ayan, mga worksheet na lang yan. Okay, so, ayan. Mabilisan na lang kasi same lang din to ng kanina. Okay? Calculate the pH during the titration of 50 ml of 0.05 molar NaO. Yan talaga tawag namin sa kanya, NaO. With 0.1 molar HCl. Okay. So again, kung ano yung sinabi, yun yung analyte. Kung ano yung unang sinabi, yun yung analyte. Okay, that is the details of your analyte, and this is your titrant. Okay, titrant. And ito yung mga volume ng titrant added. Okay. Ano gagawin natin next? Doon sa volume ng titrant that is added, you have to identify the correct stages. Okay? Kasi, if mali ka ng stage, mali yung equation mo, therefore, mali yung masasolve mo. Okay? So, we have to do it correctly. This is my question to the class. What is the equivalence point? Okay, using the equation we used kanina. Okay, again, in getting the equivalence point, that is just moles of the analyte equals moles of the titrant, or Ma, Va, Mt, Vt. So what do you think is the volume of the titrant that corresponds to the endpoint? What do you think? Anong ml yung titrant na equivalence point? I use the equation I shown in the slide. Ay, molarity analyte, volume analyte, given na yan. Ito yan. Ay, molarity titrant, yun na yan. Hanapin nyo na lang yung Vt. No need to convert the volumes into liters. Okay, so sabi Victor, 25 ml. Okay, so let's check. Okay. So to get Vt, that's MAVA over MT. Okay, so 50 ml times 0.05 ml, molar divided by 0.1 molar. Calculate tayo. 50 times 0.05 divided by 0.1. 25 ml. Correct kayo dyan. So ito yung equivalence point. Meaning, yung 24.5, siya ay pre. At yung 35.5, yun yung post. Okay? Pag kulang sa EP, pre yun. Pag sobra sa EP, post. Kailangan ba ginagawa to, sir, parate? Yes. Kahit word problem yan, nasasolve mo muna yung endpoint. Kasi, kailangan may idea ka kung anong equation gagamitin mo. But again, as I said earlier, for each stages, iba-iba yung equation. Ito lang yung nakaka-stress sa titration. Madali lang siya kapag nasundan mo na talaga. And again, no pressure naman because April pa natin siya i-continue, ha? So, no pressure na if feeling nyo, kailangan ko ba aralin to agad? Mag-chill muna kayo. No pressure. Kasi may focus lang kayo sa midterms next week. Okay, for the pre-equivalence point, what's the equation that I will use? Kung kabisado ko pa, I think kabisado ko pa, no? Nasa PowerPoint naman yun. Okay, that will be your MAVA minus MTVT. Paulit-ulit lang ang equation over V total. For the equivalence point, again, kapag strong acid, strong base, vice versa, yung pH always 7. 7 yun always. Okay. Post-equivalence point, yan ay, ito yung equation yan. So, excess acid yung hinahanap. So, MTVT minus MAVA over V total. Okay. Check ko kung tama yung mga naalala kong equation. Anyway, nandito naman yun. For the pre-equivalence point, ito yung equation. So, MAVA, MTVT. Tama yung naalala ko. For the post-equivalence, ito yung equation. So, MTBT, MAVA. Okay? So, yan. Given that, plug in na lang. Okay? So, plug in kayo ng numbers. So, MAVA, MTBT. Yung MAVA, given yung parate. Okay? So, 0.05 molar times 50 ml. MTBT, VT naman. So, 0.1 molar times 24.5 ml. And then divided by the volume total. The total volume is 50 ml of the analyte plus 24.5 ml of the titrant. That will give you the OH. No? And then, yung OH, gagawin mo siyang POH and then pH. So, ano yung pH? Sige. Kaya naman. Gamitin nyo yung sinulat ko na given and then hanapin nyo yung pH. So, makukuha nyo dyan is the OH concentration, convert it into POH, and then you convert it again to pH. Okay? Sige, I'll give you some time. So, try to look for the pH of that 24.5 ml. Okay, according to Kyla, 10.83. Okay, check natin. For the others, check nyo rin kung tama. Okay. So, ayan. Okay, so parenthesis muna. Tapos 0.05 times 50. Ano wala? Minus 0.1 times 24.5. 50 plus 24.5. Okay, so this is the OH concentration. Yan yung OH concentration. Kunin ko yung POH. So, negative log lang yan. This is the POH, 3.17. To get the pH, that's 14 minus the POH. Okay? So, 14 minus the POH, the answer is 10.83. Correct. Kailangan yung ganito, mabilis na kayo, ha?
pindot-pindot na lang talaga. Okay? So, kasi kapag mabagal pa rin, mas lalo kayo mahirapan sa quiz. So, kailangan medyo speedy sa pag-answer. That will be 10.83. That's the pH. When we have 24.5 ml of the titrant. O yun, equivalence point, wag na kayo mag-solve kasi always 7 yan for strong acid, strong base titration, and strong base, strong acid titration. Pare-parehas silang 7. How about the post-equivalence? Hindi na ako maglalagay ng ipa-plug in. So, just give me the pH. Okay. Tignan nyo na lang kung ano yung ipa-plug in and then give me the pH. Okay. So, what is the pH of the solution? Yung given, molarity ng titrant, 0.1. Volume of the titrant, 25.5. Tapos yung MAVA, pare-parehas lang yan. Ito lang yun. Ulit-ulit lang yan. Okay? So, yun. Try to get the pH. Ah, 3.18 daw ha. What the others? Yan din nakuha niya. Okay, check natin. So, ikakalki ko na lang. Okay. Nasa next slide kasi yung sagot. Okay. So, MTVT. Dito na lang yung calculate. Molarity titrant, volume titrant. Okay? So, titrant. Ano yung titrant? Yung HCl. 0.1 times 25.5. Ang analyte, yun at yun pa rin yun. 005, 50. Ulit-ulit lang yan. Now, the total volume is 50 plus 25.5 titrant. Diba? So, this is the concentration of your acid. Yan. Okay, ayun. 6.62 times 10 raised to negative 4. So, H plus na yan, no? Acid concentration na yan. So, to get the pH, you just get its negative log. 3.18, correct. Okay. Yan. So, yan. So, that's the answer. Okay. So, kapag dinamihan ko yung volume ng titrant, huwag kayong ma-intimidate. Basta alam nyo yung stage, alam nyo yung equation na gagamitin. Okay? Ayan. And always, ang equivalence point ay 7 for SASB, SBSA titration. For both of them, yun yung equivalence point. Okay? So, yan. Ganun lang. Okay. Meron din akong ginawa niya na ganito. Ipopost ko na lang to sa Canvas. Kasama ng worksheet. Okay. This is for SBSA titration. As you can see. Tanggalin ko lang itong first derivative. Okay, so ganun din. Okay, so dito, ito yung volume of titrant, for every 0.5 ml increments. Okay, so 0.5, 1, 1.5, etc. Kailangan alam mo yung stages mo dapat, of course. So I have here my initial, pre-equivalence, equivalence, and then post. Then, just using the equations that we have, ito yan, yung mga yan, naka-generate ako ng pH, no? So, ito daw yung pH. As you can see, it decreases. And then, until it reaches pH 7 for the endpoint. And then, adding more acid will cause it to drop further. Kaya naging ganyan yung curve. Uli, ganito yung ating prop set ha. Ipopost ko na lang yung details after the midterm exam. Okay, pero ganyan yung ating prop set na. Nagawa lang kayo ng titration curve. Okay. Sa weak acid strong base pati weak base strong acid, medyo kakaiba yung curves nila, pero i-discuss na lang natin sila sa susunod. Okay, so yan, this is just an introductory part of the titration process talaga na. So siguro try nyo na lang sagutan to, tapos ipopost ko na lang yung answer sa ating worksheet. Pero wag muna kayo ma-pressure. Okay? Hindi naman kailangan aralin agad siya. No? Kasi April 4 pa natin ulit ito babalikan. Okay? No pressure. So, for weak acid strong base, ito yung mga equation. Mas malala. Mas malala siya, to be honest. Okay? Ayan. Pero di-discuss natin to next time, ha? Next time na. Okay, so mas malala yung kaganapan dyan, pero kaya yan. Then for polyprotic, sobrang dami na ng equations, like ganyan siya karami. But don't worry, hindi tayo gagawa ng ganito kalala. Ha? Hindi natin gagawin yan. Huwag natin pahirapan ang ating sarili. Okay? So monoprotic lang talaga tayo. Okay? So monoprotic. And again, just to give you an insight, parehas lang to sa laboratory. So sa class ko mamaya sa lab, parehas lang yung i-discuss ko. Pero yung second part ng is doon na sila magkaiba. Okay? So it's up to you kung attend kayo mamaya kasi parehas lang yung first part ng discussion. Just to give you an insight, ito yung itsura ng PowerPoint. Obviously, not that one. For the laboratory, okay, yung first part ng discussion, very same lang. Ayan. And then, yan, di ba parehas lang din. Pero I think mamaya sa lab, baka madaanan natin yung weak acid, pati weak base. Kung gusto niyo magstay mamaya sa lab, pwede natin gawin. Tapos i-continue na lang natin yung buffers sa susunod. So, mamaya pala sa lab, madadaanan natin yung weak acid, strong base kasi mas matagal yung time natin doon. Okay? Sabihin, mabilisan na lang ulit tayo sa SASB, SBSA kasi parehas lang ang given. Okay? So sa class ko mamaya, ito, mag-weak acid na tayo sa lab. Yung buffers, next meeting na lang. Okay? So anyway, just as I said kanina nga, we are not really that much pressured to understand it agad, no? So wag kayo ma-pressure to understand this topic ASAP kasi we will continue this by April pa, no? I just want to at least give you an insight on what will happen by April. Okay? Medyo malala siya. Pero ang dami kasing equation na, but as long as you know the stages, madali lang. Okay? So again, I'll give worksheet sa inyo. Pero saka na lang yung worksheet. Just focus on your upcoming exams. Okay? So yun. So, pag may question kayo, wag din mag-hesitate mag-chat sa MS Teams. Okay?
Yun lang. And I think that's enough for our session today na. We'll continue this by April 4. Matagal pa uli, April 4 pa. Because next week is your midterm exam. March 28 will be your midterm consultation. And then April 4 will resume everything. Okay? So yan. Okay, so again, wag mai-intimidate. Madali lang yan. Basta alam ang stages. Okay, so with that, I guess that's it for today, no? So thank you sa inyong mga umattend, and I wish you all the best sa upcoming midterms. I know na medyo busy talaga na recently, so I hope na kayanin. When it comes to my class, i-adjust ko naman yung mga deadlines. And I think it is indeed necessary to adjust the deadlines. Okay? So I'll see you again sa April 4 na lang, ha? So pwede kayo mag-advance study na. Okay? So, do you have any questions? Kung wala na, I guess we can call this, we can call an end to this session na lang. Okay? Sige, thank you for attending. I'll see you again next time. Dun sa mga lab students mamaya, madadaanan natin yung weak acid pati weak base. So if you want to learn about it, stay kayo later, ha? So see you and good luck with all the exams. Bye-bye.
Thank you, sir.
Bye po.